Building an AI to play Go, Part 2. After my AI failed to make a move, I decided to cut down the depth of the state tree constructed by the Minimax algorithm. I created a variable set to 2 and passed to the Minimax function. When the depth of 2 is reached, instead of assigning 1 or minus 1 to the leaf nodes, I used the difference in number of stones as the utility value. Now that the AI is only considering 2 steps ahead to make its decisions instead of the 25 total moves, I expect my AI to be less intelligent than what I had initially planned. I started the game with my AI as black and I played white. It played somewhat intelligently as I could see it capturing my stones. It took several intelligent choices and I was impressed, but it failed to anticipate my trap and lost at the end. This is very interesting because the Minimax algorithm with depth of 2 captures the opponent as fast as it can and gives the most aggressive AI player. This is expected as depth of 2 only considers the immediate 2 moves to take its decision and captures the stones that are within its grasp. But in gameplay, being aggressive is not often rewarding. In strategy games like Go, it is more useful to be patient and play with technique than just be aggressive. But any depth greater than 2 meant having to wait for several minutes for the AI to make its move. So the challenge is to increase the depth of the state tree without losing the time efficiency. I implemented a technique called alpha-beta pruning, which helps with making game tree traversal much faster. Alpha-beta pruning is an intelligent tree traversal method for Minimax algorithm. When the values are calculated bottom to top in Minimax, the branches which cannot influence the values of the parent nodes are not explored at all. This pruning cuts down the number of nodes to traverse in the state tree and improves performance. I also refer to a research paper which claims placing the first stone closer to the center of the board increases winning chances substantially. So I programmed to place the first few stones closer to the center of the board and then use the Minimax algorithm for the rest. These two changes should theoretically improve the performance of the game without affecting time. I started the game and was disappointed to see my AI performing poorer than the depth of 2. For example, instead of capturing opponent pieces, it was making bad moves, and even worse, it was making the same bad moves repeatedly. I played around with different depths and realized the depth of 2 is actually the best and decided to improve my AI in other ways. Follow me for part 3 of this series.